Hey there! Welcome to this explainer, designed perfectly for your GCE Edexcel psychology revision. Today we're going to break down a really foundational piece of research in developmental psychology. We're talking about Piaget and Inhelder's incredibly famous three-mountain study. Honestly, if you want to understand exactly how children's minds develop and, secure those top marks on your exam, you are in exactly the right place.
All right, let's kick things off with a quick brain teaser to get that revision mindset fired up right away. What exactly is egocentrism, and in what developmental stage does it actually occur? Just take a quick second to test your memory before we reveal the answer.
Okay, so if you guessed the pre-operational stage, absolutely spot on. To put a formal definition on it, egocentrism is a massive concept in Piaget's theory. Basically, it's when a child in the pre-operational stage only sees the world from their own viewpoint. And I mean that literally. They cannot comprehend or see another person's perspective. It's not that they're just being stubborn and choosing to ignore what you see. Their brain simply hasn't unlocked that ability yet. Now, when a child finally overcomes this mental barrier, we say they are able to decenter, which just means they can cognitively zoom out and consider multiple views of a single situation.
Here is our roadmap for today. We'll start with the background on egocentrism, move into the sample and procedure, look at the results of who could decenter, and finish up by evaluating the study's strengths and weaknesses.
So, let's jump straight into part 1, background. What exactly is egocentrism?
Well, Piaget had theorized extensively about egocentrism, right? But he couldn't just guess. He needed to rigorously test it. So the fundamental aim of Piaget and Inhelder was to investigate exactly what age children are able to see things from another point of view. In other words, when exactly do they lose that egocentrism and gain the ability to decenter? They obviously needed a pretty clever experiment to find out.
Moving right along to section 2, the sample and the procedure. How did they actually test this?
To do this, the researchers gathered up a total sample of 100 children and noticed how carefully they broke this down into 4 specific age brackets. You've got 21 children aged 4 to 6, 30 aged 6.5 to 8, 33 aged 8.5 to 9, and finally, 16 older kids aged 9.5 to 12. Setting up this specific cross-sectional sample was absolutely crucial because it allowed the researchers to compare the different developmental stages side by side, watching exactly when those cognitive abilities start to shift.
Now check this out. They used a 3D model featuring 3 mountains. And to make sure perspective truly mattered, the mountains were built to be between 12 and 30 centimeters high and had very, very specific identifying features. Like one had snow on top, another had a little red cross, and the third featured a stream and a path. These weren't just random details, They were highly specific visual anchors, purposefully designed to look completely different depending on which side of the table you were standing on. It was basically a visual playground perfectly designed to rigorously test spatial awareness.
The procedure itself was strictly structured into 3 specific trials. And honestly, think about how difficult this actually is for a young mind. In trial 1, the kids had to arrange 3 boards to represent what they could currently see, what a wooden doll placed around the model could see, and what they themselves had seen from a previous position. Then, in trial 2, the researcher showed them a photograph, and the child had to place the doll exactly where it would need to stand to see that exact view. Finally, in trial 3, the child had to identify the correct photograph out of 10 different options to represent various viewpoints, including the doll's. A real cognitive workout.
All right, section 3, the results. Who could actually decenter?
This is where it gets super interesting, because a massive developmental shift happens right around age 7. The 4 to 6-year-olds, they consistently stuck to their own egocentric viewpoint. When asked to choose a photo or arrange boards for the wooden doll, they basically just chose their own view, or, well, they guessed entirely at random. But look at the older group. The 7 to 12-year-olds could successfully and consistently organize the task exactly the way the wooden doll would see the scene. They had officially unlocked the ability to decenter.
So, the big takeaway for your exam is this conclusion right here. Children age 4 to 6 are firmly in the pre-operational stage and remain egocentric. However, children begin to lose this egocentrism and transition into the concrete operational stage at approximately 7 years old. From this age onward, they are finally cognitively equipped to see the world from another person's point of view.
Okay, on to section 4, evaluating the study, starting with its strengths. Let's put our scientist hats on. Why was this methodology so robust? Well, the study boasted high reliability due to a highly standardized procedure. Every single child was tested using the exact same model with mountains of the exact same heights and features. That means the study can easily be replicated to check for consistency. Plus, it had incredibly high internal validity. Since it was a strict laboratory experiment, Piaget and Inhelder had full, meticulous control over extraneous variables, things like the exact color of the pictures used or the lighting in the room. This strict control allows us to confidently say that the independent variable, the age of the child, was truly what caused the change in the dependent variable, their perspective-taking ability.
Which brings us to Section 5, Evaluating the Weaknesses.
Now, no study is perfect, right? You absolutely need to memorize these 3 major critiques for a perfectly balanced exam answer. First, poor generalizability. The participants were entirely from Switzerland. It's highly possible that egocentrism fades at completely different ages and different cultures. Second, a massive hit to reliability. A researcher named Bork replicated the study later on, but instead of abstract mountains, she used a familiar Sesame Street character, Grover. By making the task engaging, Bork found that 3-year-olds could identify Grover's viewpoint 79% of the time, and 4-year-olds got it right 93% of the time. That totally contradicts Piaget's rigid timeline. Finally, the original study suffers from low task validity. The setup of arranging boards and looking at weird abstract mountains was so highly artificial that it may have simply confused the younger kids, rather than accurately measuring their actual cognitive limits.
Interestingly, though, we can have a really fantastic debate right here about ecological validity. Usually we say lab settings are artificial and lack real-world application. But here's a nuanced insider secret that will really impress an examiner. While a lab setting isn't a natural environment, the task itself, looking at mountain scenery, was actually highly appropriate and extremely familiar for children growing up in Switzerland. So you can powerfully argue it does hold some ecological validity for that specific population, simply because Swiss children interact with mountains practically every single day.
To wrap things up and really lock in your revision, let's test your memory on some actual exam-style facts. Based on what we just covered, can you confidently remember the number of pictures the participants were shown? And what was the overall sample size? I'll let you lock in your answers. Okay, the answers are 10 pictures and a sample size of 100. If you got those right, your revision is perfectly on track. But before we end this explainer, I want to leave you with a thought to chew on. If a 3-year-old can perfectly understand the perspective of a familiar Sesame Street doll, but completely fails when looking at some abstract cardboard mountains, are we really testing a child's cognitive development, or are we just testing how boring they find our experiments?